All right. Hello, my name is Tate Niekamp, and this is my Lab 1 for Physics 2. So jumping into the introduction, the purpose of this lab was to charge pieces of Scotch tape and observe interactions of the tape with objects and other charged pieces of tape. So then we also wanted to determine the amount of excess charge on one piece of charged tape. Some of the principles of physics throughout this lab was Newton's second law, F equals ma or F equals mg when you're dealing with gravity, Newton's third law, and electrostatic force, where two charged particles interact creating an equal and opposite force. And then Coulomb's law, where the electric force F is equal to K times Q1 times Q2 over R squared. So the main result of this lab was that the U-tapes repel. They have a positive charge, and the tape's charge was about 9.6 times 10 to the negative ninth. I was able to find that it was positively charged because it was attracted to a negatively charged plastic pen. If the U-tape was positive, it would have been attracted to this pen like it was. If it was negative, then it would have been repelled by this pen. If it was neutral, then it also would have been attracted to this pen, but the U-tapes would not repel each other. So since the U-tapes repelled each other and it was attracted to that negatively charged plastic pen, I was able to conclude that the U-tape has a positive charge. So going into the experiment, the model setup. So I made two U-tapes and confirmed they were charged by bringing my hand close to them. When I brought my hand close, my neutral hand, the tape was attracted to it. So I was able to determine that they had a charge. Then I determined the sign of the charge, like I explained on the previous slide. Then I placed U-tape B, the system, on two textbooks as seen in the diagram below. And I brought U-tape A close to U-tape B and observed that U-tape B would float. I measured the distance between the two tapes when they were floating and recorded it. So my predictions of this lab were that the two U-tapes would repel each other and that both tapes would be attracted to a neutral object. My observations were correct. They did repel each other, and they were attracted to neutral objects like my hand, and I also tested it with a book. So some assumptions and some sources of error for the lab was that we assume that each U-tape has the same net charge, as they were created in the same way, and also we assume that each U-tape is a point charge located at the center of the tape. We also assume that air resistance is negligible. So some of the data from this lab was that my U-tape length, both of them, was about 21 centimeters, and the distance between the two U-tapes when they were floating was about 2 centimeters. I needed to find the mass of the U-tape to determine the gravitational force on tape B, and the lab told us that a clear piece of tape like that is about 1 gram per meter. So multiplying that by the length, I was able to find the mass of the U-tape being 2.1 times 10 to the negative fourth kilograms. Going into the conclusion. So here's pretty much all the numbers here. And I got these from my glow script, so I'm going to go ahead and jump there. So here's my glow script code. And when I run this program, you'll be able to see the free body diagram on U-tape B, which is the red, and U-tape A is the blue dot below. So since the momentum on B is not changing, the net Y component of the force on B is 0. So the gravitational force of the tape pulling it down and the electric force of U-tape A going up are equal. So what I did was I found the charge of the U-tapes by setting mg, which is Newton's second law, equal to Coulomb's law, kq squared over r squared. Then I was able to use the charge formula, and I was able to find the q there by solving for q. And then I needed to find the electric field using E equals kq over r squared times r hat. So I was able to find the electric field here, and then multiplying those two together, I could find the electric force on U-tape B, which is about 2.0601 times 10 to the negative third. F equals mg is the gravitational on U-tape B, which is the orange arrow coming down, while the electric force is the white arrow going up. They're equal, like I said, so it's just in the opposite direction. Then I need to find the number of deficient electrons on U-tape B. So I did that by taking the charge of the tape and dividing it by the magnitude of an electron's charge, which is about 1.6 times 10 to the negative 19th. So this comes out to be about 5.98 times 10 to the 10th deficient electrons. To find the number of total atoms on U-tape B, I divided the surface area of the tape by the surface area of an atom and found that it came out to be 4 times 10 to the 17th atoms. So then here's the ratio of the deficient electrons to total atoms, which is about 1.5 times 10 to the negative 7th. So then jumping into my presentation again, going over the last two questions. So if electrons had a positive charge and protons had a negative charge, what would happen? So the U-tape would still repel each other, but the electric force in the field will be different since the signs swap. So they'll probably be in different signs. And so it's important to handle the tapes because they're going to lose their charge. Handle them as little as possible because they're going to lose their charge. When the tape comes in contact with my hand, discharges and turns neutral in a short period of time. So, all right, thank you for your time.